I think yes, we started. Okay.
Okay. So the columns are just like age, central exposed to risk, because the formula says, like the lecturer said, the formula is central exposed to risk.
Mhm.
So we had to adjust that to find the Q rates.
Yep.
By using the formula we learned in AM2. After that, Matt and I tried several formulas and we worked out the best one. Well, we think the best is just a quadratic formula, like log of qx on px
Yep.
is a quadratic formula plus f to the power of x, which is just another variable to the power of x. And then we use weighted least squares to find the best fit. And then these are pretty good, like in terms of fitting, because they're like 0.8.
Yep.
And then I've got 0.814, which is pretty good. So I decided to use this one. Okay, but the thing is, like cubic splines would definitely be the best fit.
Okay.
Because cubic splines can fit anything.
Yep.
It's just that the more knots you have, then the better fit it is. Like if you have like 55 knots, then it's going to fit perfectly. But the problem is in the early years, because we have to consider ages from 25 to 80.
Yeah.
Between ages 25 to 38, then the death rate actually fluctuates. Like it increases and decreases.
Okay.
Between ages 25 to 28. So it's like it's higher in for age 27 than it is for age 28. And
Okay.
then it's then it's higher for age 29 and over 28, but then it decreases again from 29 to 30.
Okay.
So because it fluctuates so much,
Yep.
then what happens is the tests, we're doing the chi-squared test and the cumulative deviations test, then they fail dramatically because it fluctuates. The data fluctuates a lot between those years.
Yep.
But, you know, the thing is, like with the mortality rates, they're not supposed to be, like,
No.
theoretically, they should increase with age, yeah?
Yep.
So this fluctuation isn't supposed to happen. It just happens to be that when we fit with the data, it doesn't work very well because
Yep.
the data's crap.
So it's the data the raw
Yeah.
data by itself. It just fluctuates. Yeah. Okay.
The raw data is what's...
Is that the red section there? So
Yeah,
that's
the
all
red section is the fluctuation part,
Yeah.
and then the yellow section is just fluctuation, but it's positive, but
Yeah.
it's like it decreases by a lot, and then it increases by a lot, and then it increases by a little bit, increases by a lot, increases by a little bit.
Okay.
So that's what the red and
not
yellow
smooth.
sections are. Yeah, exactly. It's not smooth. It doesn't really smooth. And then, like, in fact, if we just drag it out, make this massively. So the red one is you won't be able to see it there, but anyway, the red part is
Yeah.
the formula, and then the blue part is the actual data, is the raw data.
Okay.
So you can see it goes up and then down, and
Yeah.
then up and down.
So is this the cubic splines one?
No, this isn't the cubic splines. This is just this is the formula.
Or the quadratic?
Yeah, this is just the quadratic formula.
Okay.
I've got it here. Ln
Yep.
qx on px is equal to ax squared plus bx plus c
Yep.
plus d divided by x minus e
Mm-hmm.
plus f. And after the variable too.
Where did you get the fx from?
F to the power of x. It was just Matt and I were mucking around with it last night, and we just happened to find that if we include f to the power of x,
Yep.
it actually fits even better.
What is f to the power of x?
It's just like f is 0.928826.
Okay, is
It's
it
like,
just
it's
a
like an
number
exponential function.
you just found? Like,
Huh?
is it just a number that you found? 0.95?
Oh no, we
Was
used
it
to solve
given?
that. We used to solve.
Oh,
that.
right. Ah, yeah.
But I think a lot of teams want to use cubic splines because they know that it'll fit really well.
But then if it fits too well, then
Yeah,
it's
exactly.
undergraduated.
That's what I think. I think you don't want to make sure that it fits really well for here because the data's really crap.
Does cubic splines pass the tests?
I haven't tried cubic splines.
Oh, okay.
I haven't been bothered because with cubic splines, then you have to decide where the knots are.
Yeah.
And then, I mean, like, I can't be stuffed deciding where the knots are and everything.
Hopefully Amanda and Shannon did cubic splines and we can compare that.
I asked them last night. They hadn't done it yet.
Okay.
Yeah. I haven't. In fact, I only did this last night as well. Like, I only got really good models last night. Yeah, so I can tell them about it later.
It is good. Okay, awesome.
I mean, like, I think it's pretty good. I mean, when we expand it out, it looks pretty good. It's like, this is only 0.06, and that's less than, that's 6%. and then it fits like ridiculously well. So I think I would go with this model. I'd be pretty happy with it.
If we make the blue line disappear, so we just see the red one.
Yep.
I mean,
You want to get rid of the blue one?
yeah, just hide it for a moment.
Let's just move it.
Yeah, that looks pretty a bit. Yeah, that looks pretty smooth. It's a bit bumpy.
Yeah, it's a little bit bumpy here, so that it already accommodates for it somehow. I don't know how though.
Can we magnify it? Like, cause just that little part.
Yeah, I should be able to.
I wonder how hard he's gonna mark it. Like, he's gonna... Should be able to...
It's close enough. Get rid of the blue stuff in here. Blue part in here. Oops.
So we're to write 2,500 words.
Is it?
Yeah,
Is it in total?
it is.
Oh,
Each graph is 200 words.
Yeah.
That's interesting. Like, you know, in addition to what you just said before, all that stuff, and other stuff, well, I might get from a manager. Yeah, add in a few graphs.
Yeah.
And then after I finish that, I'll turn it over to you and you have a read it and see if anything I left out.
Yeah.
And I'll put it in.
So there's quite a lot to talk about, especially with the data, the problem with the data. I'm just mucking around here.
So areas to emphasise on in the report would be the data at the early ages.
Yeah, I think we have. I think we should.
It's bumpy.
Well, of course, I think we should ask Sharon and Amanda what they think about using this model instead of using cubic splines.
Yeah. So
Yeah, I think they want to use cubic splines as well. I was going to suggest cubic splines, but then I figured like really can't be stuff with cubic splines because then you have to add indicator functions and stuff, and it just makes it so much more complicated.
Yep. So you got the quadratic and cubic splines.
Yeah. I will show it here. I should just show them now as well. That's about it.
Okay, that's cool. Let's see, weekend Monday. Oh, I will. Let's see. What about Tuesday night?
Tuesday night.
Yeah, and I'll send it to you.
Yeah.
And then and then see if I missed out on anything
Okay.
or
Right.
if I'm having trouble writing 2,500 words. I'll ask if there's anything else to discuss. I haven't written something this long since like OB. And before that was just basically English.
I could run out some of it as well.
Nah, that's not
that's
it.
quite a bit.
Yeah, no. Awesome.